So in this video, I am going to talk about how to state a null and alternative hypothesis test. So for null hypothesis test, we use the notation H sub 0. The null hypothesis is the current value of the parameter. It's the accepted value or the status quo. What is the current value for flipping a coin, or the accepted value? So normally people will accept it 50% of heads up when you, no matter how many times you flipping a coin. So this is the null hypothesis. The alternative hypothesis is what we are trying to prove. It's called alternative hypothesis, and we use the notation H sub A. A stands for it's short for alternative. So for the alternative hypothesis, we only have three results: either greater than certain number, the same number that you use for null hypothesis, or less than a number, or if it's not equal, means different from that number. So here is some examples. For each scenario below, state the null hypothesis and alternative hypothesis. So an old acid provided relief for 70% of the people who use it. A pharmaceutical company has a new drug they want to test see if it's more effective. Well, what is the current value of the parameter? Well, the current value of the parameter, which is our null hypothesis, is 70% of people who use it and provided a relief. So now the new a pharmaceutical company has a new drug. So the new drug, what they're trying to prove is the alternative hypothesis, since they're trying to prove if it's more effective compared to the old one. So which means is greater than 0.5. So this is also called right tail test, since you will have a normal distribution for the sampling distribution, and we build around that with the null hypothesis. So 0.7 is going to be the middle, and you want this to be greater than, which is our p-hat. P-hat is our sampling proportion, greater than 0.7. So it's going to be anything like this one. So this is also called right tail test. Okay, now B, a company is concerned that too few of its cars meet the pollution emission standard. They have 1,500 cars. They sample 56 and find out that 43 meets the emission standard, and they want to test if less 80% of their fleets meets the emission standard. Okay, so right now, less than 80% of the fleet meets the emission standard. So that means what the current value right now is 80%, and the assumption, something that we want to prove is if the probability of that is less than 0.8, because the keyword is less than. So on the probability sampling distribution, we build around the null hypothesis, which is 0.8 is in the center, since it's less than, so it's going to be on somewhere in here. So our p-hat, which is our sample proportion, is going to be less than 0.8. This is also called left tail test. Okay, next one. In 2014, the official poverty rate was 14.8% in the US, and city official wants to test if the county has a different poverty rate than the rest of the US. So the current value, which is our null hypothesis, is equal to 14.8. So the null hypothesis is going to be 0.148, And the alternative hypothesis is something that proves that it's different. If it's different, we use not equal to. So we want to prove that the p-value is not equal to 0.14a. So that means when it comes to the sampling distribution, we're looking for p-value on both ends. So either is greater than or less than. So p-value, again. So this part is very special because if you think about it, this is a normal distribution. For normal distribution, everything is symmetric. That means this area on the left side is going to equals to the area of right side. So that means the total p-value should times 2 since they equal. This is also called two-tailed test. All right, now is the second step and third step on how to set up a sampling distribution. We want to build a distribution around the assumption that the null hypothesis is true. This gives us an idea of what we expected to be true for the population. Then we can see where our sample statistic lands in comparison. So, after we set up the null hypothesis, or the alternative hypothesis. The second one is we want to set up the sampling distribution. So we need to check the central limit theorem, 3-part independent, randomization, and the success failure condition, which means the sample size times the success proportion equals to 10, greater than or equals to 10. Also, n times q is greater than or equals to 10. Okay, the third step is set up the sampling distribution of proportion and calculate the test statistic. So this is two different methods, but you should get the same result. Okay, so for sampling distribution of proportion, we build the mu p hat equals to p, which is our null hypothesis p, and then the sigma p hat, which is the standard deviation for the sampling distribution of a proportion, is equal to p times q over n, and then take square root. For t statistic, test statistic, sometimes they call it t statistic, we want the z-score equals to the p hat subtract mu and divided by the sigma of the sampling distribution of proportion. In this case, our z-score, this is going to be our z-score, follow the normal distribution with mu equals to 0, sigma equals to 1, and then we can find our p-value. For example, A, an old antacid provided relief for 70% of the people who use it. A pharmaceutical company has a new drug and they want to test if it is more effective. So in the first step, we really set up our null and alternative hypothesis. That's the first step, which is the carbon value is 0.7, and they want to prove if this is more effective, which is greater than 0.7. Now, the second step is we use central limit theorem, independent, randomization. Now, the success and failure. So how many people they tested? Well, they assume it is 50. So 50 times 0.7 equals to 13.5. This is greater than 10. M times Q, which is 50 times 0.3 equals to 15, also greater than or equals to 10. So that means the success and failure condition meet. Okay, next is p hat. P hat is the result that we got from our test. So let's set up the distribution of proportion. If we use distribution of proportion, our mu p hat is equals to the population proportion, which is 0.7, and then sigma p hat is equal to p times q over n, which is 0.7 times 0.3 over 50, which is 0.0648. Okay, so our p hat follow a normal distribution with the mean is 0.7, sigma is 0.0648. Okay, the second method we want to use is the z-score, which is the test statistic. So for the z-score, we got z-score equals to p hat subtracting our mu p hat over sigma p hat. So p hat they give you is 0.75 subtract 0.7. Earlier we already calculated sigma sub p hat, which is 0.64a. So our z-score is equals to 1.5432. Remember that the z-score is follow a normal distribution with mean equals to 0, sigma equals to 1. Okay, so now B, we will use the same way to do that. B is, look, our null hypothesis is the current status, which is 80% of the fleet meets the emission standard. But the alternative is something that we are trying to prove is less than 80%. And central limit theorem, we already did that. Let's say they already check because the success and failure condition, we have m times p, n is equals to how many cars they testing? Well, they tested 56 cars times 0.8 is greater than 10, and then MQ is 56 cars times 0.2 also greater than or equals to 10. So that means we can apply sampling distribution of proportion because they meet the central limit theorem. All right, now how do we set this up? Well, first is if you want to set up a sampling distribution of proportion, you want to have mu of p hat, which is equals to the current p hat, which is the null hypothesis, 0.8, because we build around the null hypothesis. So the center must be 0.8. And then sigma p hat is equal to square root of p hat times q hat over n, which is 0.8 times 0.2 over 56 cars. Square root of that is equals to 0.423. Now I'm going to erase this part since we already did it. This is from example 1. All right. So that means our p hat going to follow a normal distribution with mean equals to 0.8 and sigma is 0.423. Oh, sorry, I calculated this wrong. Should be 0.0534. 0.05345. So that's the sampling distribution of proportion. If you want to use the test statistic, we need to find out the z-score. Z-score equals to p hat minus our mu hat over sigma hat. So p hat is equal to what? P hat is what's the proportion in your sample. So look, the proportion right now is 14.3 car out of 56 car meet the emission standard. So that means our p hat is equal to 14.3 divided by 56. In this case, 14.3 divided by 56 is 0.7679. That is going to be our p hat. So our z-score is 0.7679 minus 0.8 divided by 0.05345. That is going to be our z-score, which you expected a negative number because it's less than. Okay, well, I calculate the z-score is equal to negative negative 0.6006. All right, next one. Into Okay. In 2004, the official poverty rate was 14.8% in the US. So that means the carbon stature null hypothesis is 0.148. And the alternative is we want to prove that their county has a different poverty rate than the rest of the US. So that means it's not equal to 0.148. Since they didn't give us a sample size, let's say the rate n is equal to 300. All right, for central limit theorems, that is our second step. Independence, we'll check. Randomization, we'll check. And the success and failure, also check, because I made the sample size big enough. But in your exams or homework, you need to show me that, hey, these two, the success and failure condition, are met. All right, so now, let's say the sample we got, which is from this county, the rate we got is 12.1%, which is less than 14.8%. Okay, so the first step is we want to set up a normal sampling distribution of proportion. Our mu p hat is equal to our current hypothesis proportion, which is equal to 0.148. Our sigma p hat equals to 0.148 times 1 minus 0.148 divided by 300. That is the sample size that by given. So our sigma is equals to 0.205. All right. And then we want this to be the probability of p hat is less than 12.1%, which is 0.121, is equal to what? So remember that our p hat is going to follow a normal distribution with the mu is 0.148, sigma p hat is 0.0205, and we try to find out if this is equal to what. Now let's take a look on our GeoGebra. This is 0.148, and the sigma is, and we want to show that x is less than 12.1. All right, so this gives us is 0.0939. All right, so this is 0.0939. But remember that this is a two-tailed test. So that means your p-value should equal to oh, sorry. So should equals to what we get the probability, and then multiply by 2. All right, let me calculate that very quick, which is the total p-value should be 0.01878. Now, how do we calculate that with test statistic? If we want to use test statistic, what we're going to do is we need to find out the z-score. Z-score is equal to p hat minus our mu sub p hat and sigma sub p hat. Our p hat, as we found out, is equals to 12. The sample proportion is 12.1%. Subtract our mu, which is 14.8%, divided by our sigma, 0.05. That is equals to negative 1.317. Now, let's use GeoGebra to test if we got the same. So our mu is 1. This is 1, and then less than 1, negative 1.317. So we got the same result because they both equals to 0.0939. Okay, in the first part, we already proved that whether we use sampling distribution or proportion or we use test statistic, we proved that, hey, they both have the same p-value, the same probability, which is 0.0939. And then don't forget that you need to multiply by 2 to get the final p-value. All right, the next step is how do we test a p-value and how to write a conclusion. So a right-handed test is when we're trying to prove something that is bigger, greater than what the current status is. The current status is our null hypothesis p, and bigger or greater than, so we expected our p hat is going to be on the right side of the normal distribution. This is our p-value. And for the left tail of the test, we're looking for something on the left side of our center. That is going to be our p-value. So for two-tail test, which is the test that we did in the last problem, so we have the null hypothesis in the middle, and then two-tail test means you see some keywords about different than what they have in right now. So the p-value is going to be double of what you found out. You need to times 2 about that. Okay, at this point we have two choices. Either we reject the null hypothesis. We do this when the p-value is small. So that means when we reject the null hypothesis, we will say, hey, there is the evidence for the alternative hypothesis. Or the other choices is we fail to reject the null hypothesis because the p-value is not significantly small. So we say we fail to reject our null hypothesis. And there's not enough evidence for the alternative hypothesis. Why do we only have two choices, either reject or fail to reject the null hypothesis? Because everything is built around our null hypothesis. So that means we either fail to reject or we reject. Okay, so far we've been a little bit vague about regarding the p-value being small enough This is because how small a p-value needs to be depends on the context. So there is a significant level, alpha, is the threshold for which we can reject a null hypothesis. The most common significant level is 0.05. This means we reject the null hypothesis as long as the p-value is below 0.05, which is 5%. You might see larger significant levels such as alpha equals to 0.1 when the result don't have a very serious effect in medicine, where the consequence of missing something that can be desired, you will see a smaller significant level such as 1%. So what does that mean? Now let's take a look. So this is our null hypothesis, p hat, and then this is what we're testing, what we got for the p-value. So let's say in this case we found out our p-value is equals to 7%. So that means this area is 7% of the total area. That is the probability. So we will say if our significant level is 5%, which is alpha equals to 0.005, then our p-value equals to 7%, alpha equals to 5%. That means our p-value is greater than alpha, right? Because 7% is greater than 5%. Then we will say, hey, our p-value is not significant small. If it's not small, then what happened? Well, then we fail to reject the null hypothesis. But condition can be changed. But if I change our alpha 10%, well, then our p-value, which is equal to 7% by calculation, alpha is equal to 10%. That means our p-value is less than our alpha, right? So that means our p-value is small, is significant small. In that case, we reject the null hypothesis. Because of the p-value is significant small, it's smaller than the alpha. So it really depends on case, how do they set up, what do they want for alpha. Some people want 1%, some people want 10%, some people want 5%. So here is the example. For each scenario, decided whether to reject the null hypothesis or fail to reject the null hypothesis. All right, now let's take a look. A company is concerned to few of its cars meet the pollution emission. They have 1,500 cars and they sample 56 cars and found out that 14.3 meet the emission standard. They want to test if it's 80% of the fleet meets this emission standard, and they run the hypothesis test and found out the p-value is 0.009. Okay, if they didn't tell you what is the alpha is, which is our significant level, the default is 5%. Okay, so our p-value equals to 0.0009, which means our p-value is way smaller than our alpha. Then we can say our p-value is small. If the p-value is small, we will reject the null hypothesis, and there's evidence for our alternative hypothesis. In this case, we will say more concrete, more detailed. So what is our alternative hypothesis? Well, the alternative hypothesis less than 80% of their fleet meets the emission standard. Okay, now the next one is, well, 14% is our null hypothesis. 14.8%. And we want to test that they have a different poverty rate than the rest of the US. He runs a null hypothesis, and our p-value is different. In this case, the p-value already times 2 for you. So we got our p-value equals to 0.073, and our alpha still is 5% significant level. If they didn't say, we assume the default is always 5%. So our p-value is greater than alpha. So that means p-value is not small. So that means we fail to reject the null hypothesis. So that means we don't have enough evidence for the alternative hypothesis. In this case, you need to be specific what alternative hypothesis it is. In this case, it's going to be there's not enough evidence for their county has a different poverty rate than the rest of the US. Okay, next. Okay, so drugs that prevent seizures sometimes have unwanted side effects such as depression. A researcher wants to study such drug and look for evidence that side effect exists. She runs an hypothesis test and found out the p-value equals to 0.06. Alpha is equals to 5%. So that means our p-value is greater than our alpha, right? 6% is greater than 5%. That means our p-value is not small. If it's not small, that means we fail to reject the null hypothesis, and there's not enough evidence for the alternative hypothesis. Alternative hypothesis is something that we're trying to prove, so that means there's not enough evidence for the drugs have side effects, or the side effect exists. Okay, I know that this video is very long, but I hope you learned how to use and set up a hypothesis test.